Hello everyone, welcome back to CloudOps Craft. Today we are going to discuss about Docker, like introduction to Docker and why architecture matters. Okay, so the thing is, let's start with a simple question. When you say you are running Docker, what's really happening behind the scene? Most developers think Docker is just about typing Docker run in the terminal and suddenly having a container. But behind that simplicity, there is a very well designed architecture. Docker is like a restaurant. You consider you the customer, place an order, that's your Docker command. The waiter, which is Docker client, takes your request. The kitchen staff, which is Docker D, prepares your meal using integrants, which is image. Finally, the dish is served, which is a running container. Without understanding this process, you are just eating the food without knowing how the kitchen works. Today we will go deep into the kitchen. Okay, so like the thing is, the flow will be Docker, like you. Okay, you will contact. Well, let me zoom this. You you will you will contact Docker client. Client will contact Docker D. Docker D creates images. From the images, we are running the containers. This is the flow, right? So let me explain. So if Docker is the restaurant, what could be the equivalent of a recipe book, which is Docker file? Okay, let's discuss about Docker client. Docker client. The thing is, Docker client is your main entry point into Docker. Whenever you type a command like Docker run nginx, for example, you are actually speaking to the Docker client, which then translates your request into an API call. The client does not directly create containers. Instead, it communicates with Docker D over REST APIs. Think of the Docker client as your food delivery app. You don't cook, you just send an order. Okay, here while coming to type of clients, there are three type of Docker clients out there. One is Docker CLI. Okay, the terminal command tool. Okay, you can run Docker PS, etc. Second is Docker API, a REST API that allows automation tools to communicate with the Docker. Third is Docker Desktop, a GUI based client for Windows and Mac users. Okay, so whenever you type a command, okay, so the flow will be whenever you type a command, it will go to Docker CLI, like in Docker CLI, Docker CLI to Docker REST API, REST API to Docker D. Okay, so what happens if you run a Docker command on your laptop, but the Docker D is running on a remote server? Just pause the video and let me know if you have answers. The thing is, the client is just forwards the request. The Docker D does not have to be local. Okay. Next is Docker D. Docker D. Actually, Docker D is the real workhorse. It listens for commands from the client. It manages Docker objects like images, containers, volumes, and network. It ensures containers are running and isolated. For example, Docker D is the chef in the restaurant kitchen. Okay, the waiter, which is our Docker client, does not cook. They just pause the order. The chef, which is Docker D, knows where the integrants, which is images, and how to prepare them, and finally serves the meal, which is our container. Docker D can also talk with other uh, others to manage containers across us multiple servers. That's how Docker Swarm or Kubernetes node work. Okay, so the major responsibilities of Docker D is listen for the request, manage images, create containers, handle networking, manage volumes, communicate with other uh, daemons. Okay, so what do you think the Docker client and Docker D are separated instead of being one single program? If you know the answer, just pause the video and let me know in the comment section. The major reason is flexibility, security, and remote communication. Okay, so now let's discuss about Docker objects. Okay, to understand Docker architecture fully, you must know the key Docker objects. First is images. Think of them as a blueprints or recipes. Immutable, they don't change once built. Okay, and images are built using Docker files. Okay, so second is containers. It is a running instance of an image. They add a writable layer on the top of the image, lightweight and isolated. Okay, third is volumes. Persistent storage managed by Docker. Without volumes, data vanishes when a container stops. It's like a notebook where you keep your recipes. Even if the chef changes, the notebook stays. Fourth is networks. Any idea on networks in Docker? If you have any idea, just let me know in the comment section. The thing is, networks, what is the purpose of networks here? The thing is, it will allow containers to communicate. Docker provides bridge, host, and overlay networks. It's like a restaurant delivery system where whether dine-in, pickup, or delivery networking makes the meal reach you. Okay, so while coming to Docker objects, images, which is the content, with the help of images only we will create the containers. Volumes, which is for persistent data. Networks for container communication. Okay, so how they work together? So now we need to learn the life cycle walkthrough. Okay, let's tie it all together with the real life cycle. Okay, when I type docker run nginx, okay, when I type docker run nginx, the Docker client checks if the image is available locally. If not, Docker pulls it from Docker Hub. Docker creates a container from that image. Nnetworking and volumes are created. Container starts and access it. Okay, so the flow will be Docker run nginx to client. It will go to client. From client to Docker D. Okay, from Docker D, it will check the image. If no, it will pull from hub. Okay, and it will create container, and after that we will configure network and volume, and we'll start the container. Okay, here you can ask one question, like since it's a recorded video, so I'll ask, okay, why does Docker need to layers images instead of storing a whole new copy each time? The thing is, the major reason is efficiency. Shared layers saves disk space. Okay, so this is all about this architecture. In next class, uh, like in next video, we will create uh, your first Docker container. We will set up Docker and we will create your first Docker container. Okay, if you like this breakdown, subscribe to CloudOps Craft. We will simplify cloud and DevOps concepts every week. Thank you.